Hello everyone, welcome back to the second part of molecular docking tutorial. I am Amrita Mukherjee. I'm a PhD student working with Professor Sanjeev Srivastava at IIT Bombay. So in the last video, we have learned about the basics of in silico molecular docking and drug repurposing, where we have gained some knowledge about various repository databases from where one can retrieve and download the protein and ligand structures. Then we learned about how to curate those structures, and finally, how to perform in silico molecular docking using PyDex. Now, in this video, I'm going to show you how to deal with the output files, which we got from the previous docking analysis using PyDex. Here we will first learn how to split the output files and then how to perform a 3D visualization using some software such as PyMol and Discovery Studio. We will also learn about some web-based online tools such as PLIP that can dissect the biochemistry of a protein ligand complex very well. So here I have pasted all the important links to download the tools or the software mentioned above. You will get the same links in the description box or in the brochure provided. Now let's move on to the analysis part. Once you complete the docking with the ligands, you will get various output files. Okay, so in this PC, I have done the dockings. So one of them will be the protein itself, which is 6I3F. This one is the protein. And the others will be the docked ligands. Now, ligand files will appear as dot output files. So these are the output files. And one single output file is a compressed file of multiple docked poses combined together. And you need to split it further in order to get all the possible combinations separately. And now here I'll show you how to do that. So let's copy these files in a folder. So I have copied the files in my folder. It's called the summer camp folder. So previously we have done the docking using Autodock Vina, right, in the Pyrex software. So to split the output files, we will use a command. It is called the Vina split command. So when you run the command on your system, it will generate multiple docked poses on the ranking of binding energy calculated. Now, if you're using Windows, you will simply open the tool called command prompt. Or if you're using the Mac or Mac, you will use a terminal. Now go to the folder you have kept all the necessary files. So here is my folder, and copy the path. So I have copied the path. Now I will set the directory here in the command prompt. Now to set the directory, I'll type cd, which is change directory space, and then I'll paste the directory. So now it recognizes the directory where my files are there. So next, what I'll do, I'll go back to the folder and I will select the ligand I want to split. So for example, I'm going to split this ligand, and I'm going to copy and paste its name. Now go back to the terminal. You need to write one more code or the command in order to split that particular ligand. So to do that, write Vina /split space dash input space, paste the name of the ligand and .pdbqt and enter. And you will see back in the folder, different poses are generated from a single file. So here, 9 different poses are generated for a ligand, depending on different binding energy score given by the Autodock Vina. Now, the more the negative binding energy, the better the docking pose. In general, pose 1 has the most negative binding energy, and hence we will take it further for future use. And we will right now deleting the other poses. Okay. Now, once you have extracted the best docking pose from an output file, you are all set to visualize the docked complex in 3D. For that, you need to use 3D visualization tools such as PyMol and Discovery Studio. We will go through them one by one. So, PyMol is Yeah, so PyMol is an open source molecular visualization tool, a platform by Schrodinger. It can produce high quality 3D images of molecules such as protein and drugs, and you can um, access the unpaid version of the software by registering the educational use only version. Here they will provide you the student key for the free access. Now, once you install the PyMol, you will see an interface like this. So this is a single open tab. You can open multiple tabs simultaneously. So new with the new PyMol window to do more than one analysis at a time. So on the top of the screen, the PyMol has its major tools, and we will use some of them today. So when you click on the File tab, so a lot of you'll see a lot of options are popping out. So now to load the protein, you need to click Open. Now go to the folder you have downloaded all the proteins. So I have downloaded here in the downloads summer camp. So this is the protein I'm going to load. So here the protein has been loaded. So similarly, you can load the ligand from here. So open. We will choose the splitted ligand, the which is we kept output ligand 1, and here it is loaded. Now, once we have loaded both the ligand and the protein, I will click the reset button. It will take the protein and the ligand complex to the center. Now we can play with all the tools. Now at the right hand section, there are few extra tools. You can see A, S, H, L, and C. So A is for actions. You can command multiple actions from here easily. S for select. You can, if you need to perform few actions specifically, you can select and then play with the action. And then H is for hide. And L is for label, and the C is for to change the color. And I'll show you one by one. Now, if you want to know more about the protein, you can go to the display section, and you can click the sequence. So it will provide you all the amino acid sequences of that particular protein. So now if we click any one of the sequence, it will appear in the workspace or the 3D structure here, so that you can easily locate which amino acid lies at what 3D platform of the entire structure. Now, there are tools like display. Display is a very versatile tool, and we are going to work with this a lot. So we can change the background from here. So go to display, change the background. I'll prefer to keep it white. So the display tab has other handy tools as well. For example, you can zoom into 4 angstrom sphere. Then you can again change the color space into CMYK or PyMol. I'm keeping it default. Right now, I'm skipping other tools as they are useful for a bit advanced stage and you might not need as a beginner. Now, if we need to see the ligand binding pocket of the protein and more closely, we go to the right sidebar of all and we select actions, preset, and then ligand sites. So this will show you all the amino acids that are involved in ligand interaction. So these are the amino acids that are in close vicinity to the ligand, and these the yellow dashed sites. These are the potential interactions that are happening between the amino acid of the protein and the atoms of this particular ligand. Right. Now to visualize it better, you can change the protein color and the ligand color. I'm going to do the same. So go to the right tab. So this is the protein. I'm selecting the C of this protein tab, and I'm doing changing the color of the protein to salmon, and I'm changing the color of the drug to cyan, which is this thing. Now you can see and visualize the proteins a bit clear. So you can play with any other colors you want. So it's a fun thing. So the next useful tool is the wizard tab. You can also here we can explore one very useful tool, which is the label, right? So you can label any molecule. I'm going to label the amino acids present in the ligand binding pocket, which might play a crucial role in ligand binding. So for that, you need to click the label. So I'll select the mode to residue number to residue name to residue number. So this way, if I'm selecting this, so see, it is showing this particular residue is leucine 368. So amino acids are written as a 3-letter code here in this label. So similarly, I can choose other residues as well. For example, arginine 386. For example, this particular residue, glycine, glutamine 360. So like this. So you can also measure the distance between two atoms. So for that, you need to go to the wizard tab, go to the measurement, and you can measure the distance between this atom, and this atom. So see, it is a 4.8 distance. Similarly, if you need to know the distance between this atom and this atom, so it is a 4.4 angstrom. So it gives the distance in unit of angstrom. When you're done, put press the button done. So this way, you know what are the molecules that are present in the vicinity of the drug, what are the distance between the different atoms, and if you want to save this particular analysis, so you will need to click the file, then export molecule, and we will do it as it is. I'm saving this confirmation in a default mode, which is the state is -1, and save. And you can save this file, name it docked complex. I'm naming it docked, and you have to save it is in a PDF format. So the reason why I am saving it as a PDF format is that I can use the same structure, and later sometime I can do more analysis, or I can export the same PDB structure into other softwares as well, or the web servers as well. Now, if you need to save the image in a high resolution, you can simply type in the command area ray1200, and it will give you the image, and you can simply export the image as PNG, and you can save the PNG image as here. Now that's it for the PyMol. There is one more visualizing tool we are going to explore quickly today, so which is BioVR Discovery Studio. So this BioVR Discovery Studio is also an open access software. At least some of the very useful functions are free to use here. Now, after you installing the BioVR Discovery Studio, the installation link will be provided. The interface looks like this. So I have the 2020 version, and you can use the latest version as well. So to load a molecule, go to the file, open, and select all molecules, all files. Otherwise, you won't be able to select the files. So I'm selecting the protein we have got from the docking, and the protein has been loaded. Similarly, to load the ligand, you will select file, open, and similarly select all files and open. So this time, uh, I am so I have loaded the ribbon structure of the protein. So there is one unique nature of this particular software. It enables you to visualize all the possible docked poses in a single go. So for example, if you remember, we took this particular ligand output file and we splitted this output file into 9 different poses. And in the PyMol, we used the one pose. But here I have loaded unsplitted ligand, and here it is showing all the possible poses together. So now in this ligand tab, you can see all the poses having different orientations, and you can manually select them to visualize all of them one by one. Or what you can do is that you can go to the structure, you can put an animation and you can play. So hence all the poses will be played one by one in a row. So I'll stop the animation as of now. Now to visualize the protein and the ligand together, we will select one pose manually. So for example, I'm selecting this particular pose and I'll go to the protein bar tab and I'll just copy the protein and I'll paste the protein here. So see here protein and the ligand are together visible. Now to visualize the protein and ligand interactions here, you need to go to the toolbars. So I'll go to the toolbar and receptor ligand interactions, view interactions. Now there will be a window, pop-up window in the left side. Here we need to select the ligand interactions. So once you select the ligand interactions here, this is the ligand and the protein interactions are visible. These are the sites where this is the binding pocket of the protein and the ligand. Uh, right. And uh, Discovery Studio has one more interesting feature. It lets you to visualize the three-dimensional interaction and plot the same thing in a 2D map. So you can easily check up on both dimensional features side by side. For that, let's select the define receptor. So let's go to this tab. Let's select the defined receptor and ligand. Let's select one defined receptor, which is the 6,3-IF prepared, and we have already selected the ligand here, and we will create the show 2D diagram. So you can easily check up on us. So it's a 2D diagram that has been created. Here in the Discovery Studio, you can download the image, you can save the image in other formats as well. So that's all for the Discovery Studio. So there is one more useful tool. It's a web-based tool. It's called the PLIP, which is a Protein Ligand Interaction Profiler. So if we upload the docked complex we have saved in PyMol, it will give you a summary report of all the non-covalent interactions between protein and the ligand very easily and fast. So what we have to do, so this is the web interface. We have to choose the file. We will choose the file. We'll go to our folder. So we have saved it as a docked complex. Remember, we will open it, we will upload, and we will analyze. So you will do this thing. So you can use this particular software or you can skip it. It's totally up to you. I always go for this to cross check the features. Now, the analysis will take less than 1 minute to run. As you can see, it is already done, right? So in this results section, so this is the blue colored section is the protein and the orange colored section is the ligand, and here is the list of all the interactions shown. So only a lot of hydrophobic interaction, a total of 6 hydrophobic interaction and a total of 6 hydrogen bonds are present, and these are the residue numbers and the amino acids they have listed below. So once it is done, you can click on the small molecule section and you can download the results in an XML format or RST format, whatever you prefer. So that's all for today's docking tutorial. Let's quickly see what we have learned. So in this tutorial, we have learned the process to process the output files after docking in terms of splitting them and extracting them. Then we have learned the basics of two major visualization tools, Panol and Discovery. Next, we have learned how to actually visualize the dark protein ligand complexes and find out the binding pockets and identify the interacting residues and many more features of them. And finally, we learned to operate the PLIT web server. Now, I hope you have enjoyed both the docking tutorials. Molecular docking, when performed computationally, it's a really fun activity that can be done easily with a bit of patience. So I have pasted all the important links here. You will get the links in the brochure as well. Now, thank you so much for watching the session and participating in this summer camp. Do not forget to enjoy our other sessions as well. Stay home, stay safe, and have a great day.